Good afternoon, students.
Good afternoon, ma'am.
Okay. To start with, I just want to know what is water quality parameter.
The quality of the water is the purity and domestic and industrial purposes.
Okay. So you have different parameters like first it starts from smell. Okay, that is order of water, taste, color. Okay, then the different amount that is of minerals that is present in water, calcium, magnesium, sodium. Then you have chloride, fluoride, everything. All these things determine the water quality parameter. Why it is important to know the water quality parameter? Why should we know?
For chlorination process.
Mm. Okay, chlorination because water it is undergoing chlorination process to destroy the harmful bacteria. Okay, it is an important disinfection process for the domestic water. Okay, so surely they will add chlorine to water to kill the bacteria and viruses. Okay, so when you add that, you should know the amount of chlorine that is present in the water that is coming. That is important. Okay. So this is an experiment to determine the amount of chloride that is present in the given water sample. Okay. So how many experiments you have in this?
Two titrations.
Two titrations. Okay. The first titration is sodium chloride. Standardization of silver nitrate using sodium chloride. Okay. This is a standard sodium chloride that I have kept over here. Okay. So what is your conical flask solution? Okay, burette is silver nitrate. The conical flask solution is sodium chloride. Okay, it is a standard solution. What is the indicator?
Potassium chromate.
Okay, potassium chromate is the indicator. So I have added the indicator over here and we have taken the silver nitrate. Okay, now we are going to titrate this. Okay, I am titrating this. Okay. So, if you get this reddish brown color, it is the endpoint. Okay. So, you just tell me what happens initially. When silver nitrate is titrated against this sodium chloride, what happens?
Sodium chloride precipitate was formed.
Okay, so you have the precipitate between the silver and chloride. Okay, so silver chloride precipitate will be formed initially. Okay, then after that, how do you get this reddish brown color? Why this color?
Sodium chloride react to form reddish brown.
Silver nitrate and potassium chromate. Okay. When the silver nitrate it reacts with the potassium chromate, they are indicator the reddish brown precipitate is formed. Okay, so that is the end point. Okay, from this titration one, we want to find out that only there is standardization of silver nitrate because you know the strength of sodium chloride that is given. Okay. By using this strength, we are going to determine the unknown strength of silver nitrate. Okay. So the first titration is over, and using the volumetric that is V analysis calculation V1 N1 is equal to V2 N2, you will find the normality of unknown silver nitrate. So the standardization of silver nitrate is done in the first titration. Okay. Then second titration, we will have to find. You will be given the sample water. But you know already the strength of silver nitrate. Okay, so the chloride that is present in the sample water can be calculated in the similar method. Okay, so we have to repeat the titration by varying the solution in the conical flask. Okay, here you have the standard solution. In the titration 2, you will be having the sample solution. Okay, so who can do that? Ritika, you do it. Okay, pause. Okay, now Ritika she'll be doing the with the sample water. Okay, the titration with the sample water.
We do this titration for sample water. Endpoint reddish brown.
Okay, so you're getting the reddish brown color. Okay, now you have to know the reading for the sample water. Okay, and again we'll have to use the same formula. Here also what happens? The silver nitrate first it precipitates with the chloride that is present in the water. Okay. Then after the precipitation of chloride, it reacts with the potassium chromate, the indicator, and it gives the silver chromate precipitate, which is reddish brown in color. Okay, now we have to again apply the same formula, V1 N1 is equal to V2 N2, and you can find the amount of chloride that is present in the given water sample. Did you all understand? Do you have any doubt?
No, ma'am.
Okay, students, thank you.
Thank you, ma'am.